Good morning, everyone. Today we'll see some of the examples of regular expressions. Let's say that sigma is A and B. That is, there are two symbols for this alphabet set, and we have some languages over this sigma. The first language we have in front of us is it says that x belongs to AB clean closure and length of x is equal to 1. The length of x is equal to 1 means we have strings of length 1. There are only two possible strings with length 1. So we'll say that L has two strings A and B. So the regular expression for this would be A or B. That's it. The next example, we will have all possible strings of A and B, including a null string. So the regular expression for this would be A or B whole clean closure. This is OR operation, that is union operation, and this is the clean closure. What about this? L is equal to X, that belongs to AB clean closure, that is all strings that is coming up from A and B whole clean closure. But what's the restriction? X always starts with an A. X always start with symbol A. So we will have the regular expression as, we know that this is A plus B whole clean closure. We'll get all possible strings of A and B. But the restriction, it should always start with an A. So I'll just put A here. So A concatenated with A plus B whole clean closure. Next question, it says that X belongs to AB clean closure such that X starts with the letter A and ends with letter B. So the regular expression for this would be, just put A plus B whole clean closure and put out the restrictions. The constraint is it should always starts with letter A and ends with letter B. Next question says that X starts with double A and ends with B. So the regular expression would be A plus B whole clean closure. It should always start with double A and end with B. The regular expression here would be X ends with AB or BA. So first of all, A plus B whole clean closure. We can have any string as a prefix, but it should always end with either AB or BA. It says that X has double BA as a substring. So the regular expression will be, we put A plus B, any string as a prefix, any string as a suffix, but we must have BBA as a substring. Now the regular expression for this language, string starts with double B, ends with double A, and has BABA as a substring. Try to understand the language. It says that we can have any string starts with double B. So just start writing the expression. We will have double B followed by any combination of A and B. And it must have ABA as a substring. This substring can be followed by any combination of A and B, including a null string. And the restriction, one more restriction is there, that it should always end with a double A. The string should always end with a double A. Similarly, we have this regular expression for strings having double B A or AAB as substring. So we can have a regular expression like this. The two cases, the first one is BBA as a substring, or this is the OR operator, or A plus B whole clean closure double AB, A plus B whole clean closure. That is the another condition. What we can do, we can write it in this way. Take out A plus B whole clean closure common, and then BBA plus AAB, and here A plus B whole clean closure. This is the regular expression for the given language. The language was the strings having BBA or AAB as substring. So the regular expression for this language would be strings having double B and double A as substring. Both the double B and double A should appear in the string always. So what should be the cases here? We can have first case, that is A plus B double B A plus B whole clean closure, followed by double A plus B whole clean closure. The first case is double B and double A both are appearing as a substring in the string, but double B is coming first and then double A. That is, double A is followed by double B. And there could be the second situation where double A is coming first and then the later double B is coming. So therefore, A plus B whole clean closure, double A plus B whole clean closure, double B, followed by A plus B whole clean closure. The final regular expression we will have is R1 plus R2. That is either this regular expression or this regular expression. The next question we will do is string that repeats ABA any number of times including 0. So whenever we need to repeat something, remember what we have to do. We have to take an operator, that is clean closure. So the regular expression for this language would be ABA that has to repeat any number of times including a null, that is 0 times. So put a clean closure. What will be the regular expression for this language? It says that the language will have all string of what form? A raised to the power n, B raised to the power m. Where n is greater than equal to 0, m is greater than equal to 0. So just expand for the strings. If I have A raised to the power 0, B raised to the power 0, both are zeros. So what I'll get null dot null. So we'll have a string, null string. Similarly, if I have n is equal to 1, m is equal to 1, so AB. If I have n is equal to 0, m is equal to 1, so I'll get a B. Similarly, if I have n is equal to 1 and m equals 0, so I get A. And so on, we will have patterns of string of the form A raised to the power m, B raised to the power m. What will be the regular expression for this? The regular expression will be A star. If you have to include a null, that is n goes up to 0, put star, followed by B raised to the power m, that is again it is going up to 0, star, A star, B star. Now for in this case, see, n is not going up to 0, m is not going to up to 0. So remember, we do not have null strings here. So what we have, the regular expression will be of the form A plus followed by B plus. If we have plus represents if there is a plus sign, remember we are not including a 0 or any power of 0, that is we do not have null strings. The smallest possible string in this language will be A followed by B. The smallest string we will have is A followed by B. There's a question for you all. What will be the regular expression for a raised to the power n, b raised to the power m, such that n is greater than equal to 0 and m is greater than 1? Think about it.